come down for work on this stuff.
Oh, the live stream gets the first look at our subwoofer. No one has ever seen the subwoofer outside the company. Here you go. This is it. Subwoofer bliss. Gets installed here. All your bassy goodness comes just from this guy. So.
For people saying it, the drivetrain is fully nailed down. People think it's not nailed down.
Oh,
it's fully sourced and engineered.
It's nailed down, it's sourced, it's engineered, it's going through calibration, validation now. When we have the first PI vehicles built, then yeah, it'll be driving around and we'll show you videos and numbers and how it's working.
Yeah, sounds great. Cool, so we're gonna have one of the electrical systems engineers come down to talk more about our cool approach to the zonal architecture. Looks like a speaker, someone said.
It is very cool. It is an awesome speaker. Who are we getting from electrical?
JC's gonna come down.
Oh, okay.
So we have a lot of people lined up tonight, or today.
It could end up into tonight.
It could. Yeah, this could be a long one.
We should line up the tequila shots and really get the party started.
I can talk about the Comm AI integration. Yeah, it's gonna basically be. Oh, you got it? Here's me. It's basically gonna, end up here, probably comma hardware, and it'll all integrate into the vehicle so you could install it later in the future. That's the hope. All right, JC.
Hey. What's up?
Hi, this is JC, part of the electrical systems team. We were just talking about some of the zonal architecture stuff.
You can see that she doesn't want to be there. I'm no expert in body language, but I would bet my house she didn't want to be there.
Is there anything you want to elaborate or talk about what makes it cool?
No, yeah, so we have a zonal architecture with a centralized computing system. So the idea of that means that the majority of the controls of the vehicle is split out into these areas or zones. So the actuators and the sensors that are within a region, like the rear of the vehicle, will get a dedicated, simple controller that's very lightweight. And then we have a central computer that makes the decisions regarding that controller. So it tells you when the button on the door was pressed to open the latch. And then that little simple computer can just say, I heard open latch, I'm gonna open the latch. So the reason that we've structured the architecture like that is because it makes it really more affordable and easy to test, quicker to integrate. And it makes a lightweight system. As you've seen probably a ton of times, we will get less wiring by doing.
So people are asking how many controllers.
Okay, so APTERA has 16 custom circuit boards amongst other off-the-shelf circuit boards that we work with suppliers. 10 of those are going to be the little zonal controllers.
Like that B-pillar one in there,
Like the B-pillar one, the one on the air handler. We have 2 taking care of the corners, so like the wheel pants and the doors, kind of sensors and buttons. We have a second one in the B-pillar.
Other B-pillar, yeah.
Yeah, the other B-pillar. And then we have one on the underbody that will be down by the radiator fans, and that will do some thermal control.
Okay, so that's not something I always assumed, I don't know if you guys did, that the radiator would be in the front of the vehicle, but the radiator is in the rear. So maybe it's instead of blowing air in, it's gonna suck air in from the front by blowing air out the back.
We have one up in the roof. It will actually be in the overhead console, and so that will run the brake light and the microphone and the hazard button and the screen brightness for our rear view screen. And then we'll have one in the rear that does all of the rear lighting.
Yeah.
It'll do the rear knock knock. Oh, I have one taped. It'll be down here.
Yeah.
Which one am I missing? Oh, and then there's the front. It'll be our low voltage power distribution unit one. So that will do basically the fuse box, but also our different switched buses.
Someone said fuses or breakers.
Fuses. Fuse box. Which is another piece of our efficient system. So our electrical system is going to be split up on a different triggered buses. So there's not just off and on. We have multiple stages. So there's this efficient charging mode where we only turn on some of the devices in the vehicle when we're solar charging or plugged in charging, and that way we're getting the most power into the battery because we're not wasting power keeping on like the B-pillar POC in sleep mode because we know that nobody's in the vehicle, so nobody's going to be using the knock-knock sensor at that time. Nobody's nearby. So we go in this low power state so that we're just pulling everything we can from the sun.
Okay, that's just like so smart and something that like a lot of people wouldn't have thought of, but they're thinking about it. So, you know, these guys are professional automotive engineers. They think of stuff. And I always feel great when we hear from the engineers because you feel like these are competent, smart people that are building this thing. And that's the feeling and the impression I get when I hear from the APTERA engineers, which is good, very reassuring.
And not wasting.
Cool.
I don't get the feeling they're competent and smart. I think they're dragging unqualified mainly and probably in some cases questionable as to their residency. It's amazing how we can think differently about staff. I'm not impressed by anything she had to say.
Drive the Lightning just said you sound like the most smart person here. Thank you.
I'm not. Thank you. No, there's so many smart people here. We have some great engineers. And like you said, I'm just a member of the team. We have a pretty big team doing electrical systems. And
Right.
we're doing
It's
good.
broken up into there's like a software team, right, and a hardware team.
Yeah,
that
so
both
we
work
have
together.
a harness engineer who works with the harnessing. We have some systems.
So I wonder, are they not using Yazaki anymore? That's another question I have for them because Yazaki, remember, was doing the harness, but I would have thought that would just be all done by now. But they have another harness engineer. Maybe they've decided to go with a different harness manufacturer. I'm not sure.
Systems integration people.
They decided to go with that little girl that's fresh out of school. No, I'm just having a joke there. But what we do know, and again, I'd go back to facts, is that there is no harness. There's no proven harness yet at all. What you have seen on this bink is, I would estimate, 1/50th part of a harness. There's the other 49 parts or more to be shown.
Who help us do schematic for the full vehicle. My title is Electrical Systems Architect, so I plan out the system architecture and how devices will speak to one another and what happens when you knock on the door. I am the one who asks software.
Weren't you the inventor of the knock knock?
Not inventor. Somebody came up with the idea to knock, and then I made it.
Okay.
Thing.
That's all.
Oh, so yeah, so JC's the engineer of the knock knock feature. That's cool. So that means that she's been there for.
Hang on a sec. If somebody comes up with an idea for something, that doesn't mean they've invented it. The idea is just the very start. If she made it work, she's invented it. She might not have had the idea, but she does have the invention. I get worried when people don't even know how to define things. It's much harder to build something than to define it.
For quite a while, because the knock knock was introduced like years ago, but never seen her before.
Awesome.
But yeah, we
People love
have
that.
board layout people. 16 custom circuit boards is no small feat. It takes layout, schematic, people like that.
Yeah.
And then we have a whole software firmware team. So
All right. Cool. Audra, do you want to go grab Reed by the solar stringer and bring him back?
We have
Cool. Does anyone have any?
See how happy she got as soon as she knew she was out of there.
Any questions for JC before Reed takes over?
Reed's the star of the show.
We can look at some of the stickers, right, to see.
Yeah, the stickers are our fun little thing. As we're wiring the vehicle, we don't want to have to put everything in. Like the subwoofer has dropped out. We don't want to like break components. So we have this numbering system where every electromechanical device has its own number. And then when we make the harnesses, that harness is labeled by the number. So you just go point A to point B. For everything in the vehicle, we can track the current consumption of that device. So device 821B has a certain current consumption. It's dedicated to a certain fuse. It's just our way of tracking things. So, and the stickers look cool. So
Cool.
It's a ridiculous shortcut, and the excuse is they don't want to drop any of them. They don't have them to drop.
People asking some stuff that I think you also would know. Is the harness installed in the production line? I would assume yes, right? It's installed after you get the...
Yeah, we get the body from Italy, and then we'll do the harnessing, high voltage, low voltage here, battery pack, solar.
Yeah.
honk the horn, drive it out the door.
Harnesses go in between a lot of panels, so you've got to put them in as you're going.
Right. Yeah, that sounds great. Well, you guys have been making great progress. People are very happy. They're asking, some people were asking about the connectors into the boards. Are they things that you can take out, or are they directly soldered onto the board, the wires?
So they are actually, they're a wire to board connection that's put on as the board's being made. They're called a SMT, or pick and place component, which means it's actually much cheaper than like a hand soldered in connector, because it's done with the robots. And then we can insert them, and then they're strong enough that they won't pull out during like the automotive environment stuff. So they're meant to stay in during the lifetime.
Great. That sounds awesome.
You have to have a tool to take it out.
Yeah, and they'll
tool
be
to take it
gooped
out.
over with waterproofing, dustproofing, potting. Like they won't be as
mess it up.
exposed as they are, because circuit
Right.
boards don't like water.
Right. For this this test vehicle, right?
So yeah, so they're thinking about environmental protection and like keeping it from dust and water and stuff. Yeah, they're like 2 steps ahead of us.
They're just bare boards, but
Sure, yeah, these
Yeah.
PRECs have like a bunch of components on the top. These are what we call solder samples, so there's no expensive components that can be damaged.
Yeah.
Because any board, you don't want to be touching it with your hands. You could shock the board. So these are like little safe, cheap boards for wiring.
cool. Thank you, JC.
So that makes me wonder if the actual boards for production are going to be slightly different from these. That's another question I have.
We appreciate it. Cool. All right, now Reed's coming.
Okay, this video is getting a little long, so we'll cut it off here and then we'll continue tomorrow.
I couldn't be bothered saying much through that. It was pretty much nonsense, and it wasn't very encouraging at all. It looks like they're a backyard operation, but I marvel at how the cretin just laps it up. It's like anything he has to ask questions about are just minor details, but generally speaking, everything is honky-dory. Everything's running great. Well, I don't see it that way. I think everything looks Mickey Mouse. Looks like a real backyard operation. Looks like they're not trying hard enough. And even looks like they're stalling for time. Well, that'll do from me. Until the next one. Bye for now. Stay safe.